friends, welcome to my channel. I hope everyone is doing good. Today we are going to solve another interesting string related coding problem. It's on Leetcode 3258 count substrings that satisfy k constraint 1. I recently came across this problem. I would like to discuss the logic, the approach as well as the solution how we can solve these kind of problems. If you are new to this channel, please subscribe to this channel now. Your subscription is really valuable and important for our channel. It helps and supports this channel. So let's start. You are given a binary string s and an integer k. A binary string satisfies k constraint if either of the following condition holds. The number of zeros in the string is at most k and number of ones in the string is at most k. Return integer denoting number of substrings of s that satisfy the k constraint. Okay, so we will want to find out how many such substrings are there. Okay, so we'll go through the example. S dot length is between 1 to 50, so maximum 50 characters will be there in that length. 1 less than equal to k less than equal to s dot length, and it's a binary string. Okay, so it's a 0 and 1 only. Okay, so we'll understand this problem with some example what they are saying. So we want to find out string which satisfy k constraint of either of the following. So either this holds or this holds, then that is valid. Okay, so let's take a look at this example, then it will be more clear for you guys, right? So 10101 is the string given to us, k is equal to 1. Okay, so let's take a look. So 101, so at this time, like at this point, how many ones are there? 2 ones are there and 1 0 is there, right? So it's still fine because you still hold the condition for 0, right? Okay, so you understood this, right? What is the condition? You can have maximum k characters, so maximum, either maximum 1 0 or maximum 1 1, right? So basically if both are there, then it's not true, basically, correct? So for 101 it is true, right? 101, this condition is valid. Yes, it is valid. Why? Because there are 2 ones, so that is fine, that is breaking the condition, but you have only maximum 1 0. So remember this word, either of the following condition, right? Either of the following condition, very very important. Okay, very important. So any condition is holding true, then it's true, basically. Okay, so here 101 is true. Yes, so you can count this as a valid substring. Very important point for this one. Okay, so you understood this point, right? So when you are having a 0 like this, for example, I'm explaining you so that you can understand this problem first correctly, right? And then we can discuss the solution, right? Okay, so when you have 1010, is this valid? No, this is not a valid now, right? Why it is not valid? Because number of ones here are 2. How many ones are there? 2 ones are there. Okay, and how many zeros are there? 2 zeros are there now, right? Okay, 2 zeros are there. Now it means that this condition is not holding for 0 and 1. Okay, and word is very important here. Okay, and word is very important. So this one is not a valid substring, basically. Okay, so this you understood, basically, correct? Okay, so once you understand this, now I'll explain you how we can count that substring now. Okay, so for counting these substrings, what we can do, we can use sliding window algorithm here, right? Sliding window algorithm. So in the sliding window algorithm, we will keep track of how many zeros are there and how many ones are there, right? And so that we can find out if the k constant is valid or not. So in the beginning, I have this one, right? So how many ones are there? So I'll write down one count. One is there, right? Okay, so this one is a valid substring. Okay, when I go to 0, right? When I go to 0, how many now how many zeros are there? 1 0 are there, right? So total number of zeros, right? So no problem, right? This is valid. Okay, okay, this is valid, right? Okay, when you go to 1, number of ones become 2, so there are 2 ones now. Still this is a valid point, right? This is a valid point. Okay, so far so good, right? You are understanding this. So now when you reach to this 0, very very important, now your number of zeros will become 2, correct? Okay, so no condition is holding, so k is equal to 1. It means that you can have maximum 1 0 and maximum 1 1. So is it true? right? It's not true, right? Because number of zeros are 2, number of ones are 2. So maximum is allowed as 1. At least 1 should satisfy. Now, not 0 is satisfying the condition, not 1 is satisfying the condition, right? It means that your condition is breaking now. So this 0, if I want to include in this string, it means that I have to, this is my left pointer, let's call it as a left pointer, right? I have to move my left pointer forward, correct? So this is my window basically, right? This is my window, you can say. So to include this 0 into my window, what I have to do? I have to remove the 1 from the window. So this is what my window should look like now, right? So it means that my left pointer now should point here. So this is very important point, okay? And my right pointer is pointing here, correct? Right pointer is pointing here. So this one is the index 1, this one is the index 3, right? So if I want to calculate how many substrings are there, how I can calculate? I can calculate right minus left plus 1, right? So what is right? Right is 3 minus left, left is 1 plus 1 I have to do, right? So this one will get cancelled. So 3. 3 is the number of substrings you have here basically. You can add that into your counter, right? We'll create one counter to count number of substrings. Why number of substrings are 3 here? Because I have substring 0 there, substring 1 there, and substring 0 there, right? So it means that I have total number of substrings are 3 here. Okay. After that, what we will do, we will keep again going forward, right? When I want to add this one into my window, this one into my window, what will happen? Then and obviously when this one is out of the window, I have to decrease the one count, right? So one count is 1 now. So what I'm trying to tell you is right now we are focusing on this window, okay? This window, okay? So how many ones are there here? 1 1, okay? 1 1 and 0 2 zeros, right? Okay. So now it's clear. Now what happens is, so let me just change this color, okay? So here it becomes 1 now, okay? So there is only 1 1. Now I want to move forward and I want to include this one into my window. So if I try to include this one, how many ones are there? 2, right? 2 ones are there and 2 zeros are there. So this is not a valid window, right? This is not a valid window. To make this a valid window, what I have to do? I have to remove this one, remove this 0 from my window, and then I have to add this one into my window, correct? Okay. So now this is valid window because number of ones are 2 and number of zeros are 1 here, correct? So this is a valid window because the condition holds correctly with the 0, right? Okay. And how I can calculate how many substrings are there now? Right minus left plus 1. So right is at 4, right? Right is at 4. So 4 minus left. Left is at what? This is 2. This is 2, correct? Plus 1, right? So if you calculate this, then it will give me 3, right? So there are 3 substrings here basically. Okay. So this is how I can find out total number of substrings, okay, using sliding window algorithm, and we'll keep track of that 0 count and 1 count so that we can find out whether the condition holds or not hold, right? Okay. So now uh, so for example 12 count, how you found the 12 count? So 1 is valid, yes. Then 1 0, is it valid? Yes, this is also valid. Then 1 0 1 is valid, yes, this is also valid, this is also valid, right? 0 1 is valid. So see, like this you can calculate basically, okay, and you will come to that 12 counter, okay. So this is how you can solve this problem. The main thing is how you so before we go to the code, the main thing I wanted to one more time explain it to the people for the how your window will shrink. So for example, when your window becomes like this, you added this 0 into your window. Now you are breaking the constraint because 0 is appearing 2 times here, 1 is appearing 2 times. So it means that k is equal to 1. So k is not 1 for, like, this constraint is not now valid for 0 as well as 1, right? Okay. So this is the point where you decide that I want to move my window ahead. In the sense, I want to move my left pointer ahead. So left pointer was here previously. So now I cannot take this one, right? Otherwise it becomes invalid. So my window should be this one actually, right? My window should be this one so that it becomes valid, and my left pointer should point here in that case, right? This should be my left pointer and this should be my right pointer, correct? And then this is a valid window, right? And then I can count number of substrings for this valid window, right? So this is where you will shrink the window, okay? Shrink the window. That term is important, okay? What I'm saying is shrinking the window. So that's the point where you will shrink the window, correct? Because this one that you have is causing your k constraint to break. So you have to take this one out of your window, correct? So that's what I meant to say. Okay, so enough of explanation. So let's go to the code now and I'll explain you more on the code. So this is our Java solution for the using sliding window. So count k constraint substrings is what we are implementing. String s and integer k value is given to us as input. We are going to return the count of number of substrings, right? So it's int. Let's create couple of variables, count, one count, zero count, all are zero in the beginning, right? Because we want to keep counters for how many ones are there, how many zeros are there, right? So that's why we have created that counter. Now in the for loop, in the beginning, left pointer and right pointer will point to 0th index, right? Right pointer will keep moving to the right. That's how sliding window works, right? And right is less than s dot length, right plus plus. So right pointer is moving forward basically, okay? You read the character, you check if it is 0, then you will increment 0 count. If it is 1, you will increment 1 count. So far so good, right? This is where you wanted to check whether we need to shrink the window, right? So let's checking whether we need to shrink the window, correct? So why do we have to shrink the window? Because the k constraint is not valid, that's why, okay? So how we will check it? 0 count is greater than k. This and is very important, okay? And is very important here. And 1 count is greater than k. If both are true, then only it means that your k constraint is invalid. Then what you have to do? You have to move your left pointer forward, correct? But before that, you have to make sure that you will appropriately adjust the count, right? So your left pointer is pointing to 0, right? It's 0 character, then you will decrement your 0 count because your 0 is going out of the window, okay? Out of the window, because your window you are shrinking, right, from the left side. Otherwise you will reduce the 1, right, because it's a 1 character, and then you will move your left pointer forward, correct? So what I mean to say is, if this you are taking this one out of your window, right, this one you are taking out now in this example that I explained you. So you have to reduce your 1 count because your 1 is going out of the window, correct? So that's what we are doing here. Here you will check how many substrings it can form now. How you can check? Right minus left plus 1 will give you number of substrings which are possible, right? So count is equal to count plus. So you will increment your count basically. At the end, you have to just return the count, and that should give you the number of valid substrings that will satisfy k constraint. So let's go ahead and run this code, make sure this compiles and runs correctly against the test cases here now. So all the test cases are getting passed, as you can see here. So 25 correct answer, this one is 15 correct answer, this one is 10 correct answer. So we are getting all correct answers here. Submit this code now to the Leetcode. Make sure this code gets accepted by the Leetcode, and as you can see on your left side, the code is successfully accepted on 100 percentile on performance. Extremely good solution by using sliding window algorithm. So here we have used sliding window algorithm, and I explained you every line of the code. This is how you can solve this coding problem on Leetcode. 30 to 58 count substrings that satisfy key constraint 1. Okay, so I hope you understood this clearly, and it's pretty easy actually once you understand the concept of how your window is moving and shrinking basically, right? And I explain you with this example. So if you like this example, then please subscribe to our channel now. Click on the bell notification icon button so you won't miss any interesting upcoming videos from our channel. Guys, it takes lots of creativity, time and efforts to come up with these examples for you guys and create the images. So if you really want to appreciate our efforts on this, then please subscribe to our channel now. Also share these videos as much as possible with all your friends so they can also learn how to solve these kind of problems. On this channel, we create videos to help others preparing well for their interview rounds by showing them how to solve different varieties of problems by using different computer science and programming concepts. We have more than 600 solved coding problems taken by previously as coding interview problems by big companies such as Amazon, Apple, Microsoft, Google, Meta, and a lot of big companies. And we came up with important playlists for you that you should watch if you are planning to learn more concepts of computer science programming, or if you are planning to take any interview rounds. The important playlists on this channel you should not miss are graphs, matrices, binary search trees, binary trees, problems solved by using binary search, dynamic programming, recursion, memoization, how to use and apply BFS and DFS on graphs, matrices, and trees. We also came up with important data structures playlist for you that includes stacks, queues, priority queues, min heap, max heap, arrays, array list, linked list, hash set, hash map, tree set, tree map. So everything is here on this channel, so don't miss out on those important problems. You will definitely learn a lot by watching those videos, and will give you more insight of how to approach and solve different coding interview problems. Thanks for watching this video and have a great day ahead.